Alright, I've upgraded Visual Studio. I don't know if that'll fix the problem or not, but guess we'll see. Um, okay, this is a program we're looking at now, and okay, the first part of this is really just dealing with const correctness, even though back then I didn't see the point of it. But this is making this, declaring this function as constant, meaning it's not going to change any member variables because this is within a class. Alright, so they're saying it's not going to change any member variables, so if you try to change a member variable, it'll give you an error. But there aren't any member variables in here, as you can see, so that's a little silly to call it constant when there are no member variables. However, this base class will be inherited. There are member variables there, so in the inherited class, so this will make it so that this function could not in any way, shape, or form even mess with these variables. But then again, this is an inherited function, so it's always going to be part of the base class. So, I mean, I couldn't make this change the variables of this because it's inherited from this. So, I mean, it's really almost pointless making that constant anyway. It really isn't necessary to have it there. I mean, it's kind of silly. What this function demonstrates that's marginally interesting, or this first lesson here, is really passing numbers into it. Okay, we're defining a couple of instances on the stack, on the heap. Then we're going pointer and using the pointer version of the dot operator, to access the identify function, and we're, having to typecast, the pointer itself address to it. So that's what's happening here and here, with these two pointers, which are, using, instances of these two classes here, the two derived classes. And then we're defining a pointer C that's of type sub A, and pointer C dot as equals 5. So we can access member variables with it, like you'd expect. So I mean, back then I was just really confused, so I try to ignore these notes, really. These comments that I have in here, because those books just, they weren't really very enlightening, particularly that short book. Okay, but let's take a look at what these classes do. You see these classes, they just have variable members in them, but they're going to inherit this function, this identify function from the base class. But we don't really do anything with any of that shit. Again, kind of a pointless program, really. And here I'm just showing that you can create an integer, okay, and since that function does convert it to hex, or change the C out to hex style, this converts it back to decimal, I suppose. But then I can just pass it that integer. No typecasting needed here, but typecasting is needed here because we're trying to send it the address of x, instead. And that function is trying to, the identify function only accepts integers, if you recall. So, And here I'm just dealing with structures, by the way, so this is, pretty straightforward stuff. And again, kind of ignore these notes. Okay, and that's a different lesson down there. Let's run this sucker so I can show you what the output is. Okay. This is when we first call we first call the base, we call that one instance, of, sub A and sub B, and, so we're calling that identify, or now we're calling this, function here, and passing it an integer. We're saying it constant, meaning it's not going to change anything. And since this is, we're passing variables by value, it really is not going to change the variables either. So I mean, it can't, because we're only dealing with a copy of it this way, since we're not passing by reference or pointer. So the data is safe. The data we're passing into it is safe, and the function itself is safe by default, because there's no member data here that it can access. But at any rate, that's pretty straightforward stuff. I mean, all it's showing, is that it's really what constant is all about, but I mean, it's really not even showing that. So it's really not, this lesson really doesn't teach you anything, as far as I can tell. I mean, it's, okay, we're using the constant keyword, and we're, passing a typecast variable into it right here, the pointer, or down here of this integer, the integer directly, or what have you. And you can see value of x in decimal right here. I had to convert it back to decimal, as far as the cout function is concerned, because we changed its type in that, in that class. Base class called by. So, we'll pass it this. Decimal, okay, and then right here you can see, when we call that, it's converted back to hex. And then we call it again, down here with the address of x. So, yeah, I mean, I could have just put this, at the end of this, honestly, as part of the cout statement, because that's what it really sort of is. Sort of. Well, I guess it calls the cout statement again, so within it. So I couldn't have really done that, because it's not returning anything. It just does a cout. Cout function. It's not returning anything. It's a void. So yeah, it pretty much had to be done that way. This is how the class was set up. But beyond that, I mean, it's really not, really showing you anything. I mean, it's just, it's showing you, hey, that, we can, assign pointers, because we've got these pointers. We're creating something on the heap. These are base pointers, and pointers to type base, which is interesting here. So that's, that is probably what it's trying to teach you, is that it's, the pointer we're making is of type base, yet we're actually assigning it a sub A and a sub B. So, so we're pointing the pointer actually at a new object that's a derived object of the base class. So that's showing that a base class pointer actually can be pointed at several things. And of course here we're using the identify methods of the base class, which is fine. That's to be expected because it is a base class pointer. Now here I'm defining a pointer of sub A. So and it's pointing to a type sub A class. So an object we instantiate in on the heap. But then I'm demonstrating that I can access the member variables directly with it. Okay, which is fine and dandy, but apparently I'm having some kind of a problem accessing other parts of it. But let's explore that, shall we? Let me go ahead and close this. Okay, so we have this pointer C. So I can access ass and whole and identify. I think they're all. I guess I'll have to split the screen again. This is getting kind of annoying. There's our base right there. Okay, holds a string. Well, okay. Where's that damn thing to throw out some kind of error? I just assigned holds a string object. Maybe it'll, because it is a string object. I don't know. L here just for now, just to see what this thing does. Okay, let's run that turkey and see what happens. What the fuck did that do? What generated that tone? Okay, so it's printing 5 commas. Okay, so that tells me what the string did. It just choked on it. Yeah, it just choked on it, so okay, there we go. So has full access to the members. Now let's see if okay, so the base class is looking for an integer to be thrown to it. So let me see what we should do. Okay. Hold on. Oh yeah, it's not going to allow that. Okay. Oops. I can't see it. I just got to call the function like that. God damn gnats. Okay. Alright, so basically, okay, yeah, here's what we're doing. IDK7, base class called by OX5. So basically, yeah, with a pointer you can, with this particular pointer, since type sub A, we can not only access the member data of sub A, the member variables of sub A, but also the base class method. That's not a problem. See here we got different members in sub B, but again we could do the same thing with it. But now this base class pointer, let's examine that for a minute. Certainly we can call the member or the methods, but calling the members is going to be a little inconvenient of the derived class. Because like I say, you've only got access to the identify function. So okay, so like I say, it's pretty fucking useless, unless you want to just call the identify function. I mean, why do this? And that's, really exactly what I'm trying to do down here. I'm saying, this won't work. So what the fuck, is the point to this? Why would you even want to do that? I mean, it doesn't do you any good, having something like a pointer that is, of type base class pointing to a new object when you can only access the members and methods of the base class. I mean, why create a new object in there that's kind of a waste of space because you can't access any of its members? So why do this? This really doesn't make any fucking sense. I was spot on that assessment. This really doesn't make any sense. I mean, it's totally useless. As far as I can tell. I mean, unless there's some other fucking use to it. Okay, it's interesting to make note that, you can do this, but why would you want to? And why would you ever want to? Because like I said down here, and like we showed, well, I can, set up a fucking, pointer that's, going to a derived object, and I can easily access the methods, the base class. So, and any inherited members. So, I mean, why would I want to try to go about it from the opposite direction? hardly makes any sense. You know, because again, this is the only fucking thing you can do with this. I mean, I can't access the member data at all, and you know, of course, neither can the base class. It can't access the member data of the derived classes. So again, why the fuck would you want to do that? So it's totally useless. So I'll just forget about it. You know, again, some of these books teach you just totally useless stuff. I mean, it's just, I don't get it. So anyway, and this is just dealing with the structure, which, like I said, is no big deal. Well, look at this. Here, I'll put a note here. So, okay, now this next section basically is about virtual functions, which are really totally unnecessary. I mean, again, you can see this identify function. You know, I am the parent. Okay. Now, each one of these derived functions or derived classes, you know, has an identify function which overwrites the virtual function. Okay, it's, you know, considered good practice if you're going to do that to put the word virtual here too, although it is optional. But the fact of the matter is you don't have to do this at all, as we've seen in other programs. And here we have a grandchild that's a public, you know, a third generation inheritance, you know, which is also redefining that function, even though, you know, it was not identified as virtual here. And, but like I said, okay, and that's the end of it. Now let's run this thing and see what it does, because this fucking thing is so goddamn convoluted. I just do not understand the value of the example itself, and it's hard for me to get past that, because I'm a very practically minded person, and the program is totally useless. But okay, I am the grandchild, I am the what the fuck ever, I mean, who cares? Yeah, but not once do I ever see that, hold on. But not once do I ever see that, virtual function being called. I am the parent, okay. I guess it is called here, you know, several times. Okay. But in any event, I was going to say, you know, I don't know that we need that virtual function, and the reason I wanted to run the program is just try to take a screenshot of this, and let's see if that changes. Okay, it's nice that it closed it there, but it didn't close it here. So this has still got bugs in it. Bet you IntelliSense doesn't work yet still either. Okay, base class called by, oh, we're in the other example. Okay. Now, I wanted to see, you know, if we could take that out and if that gripes at me or not. So, yep. Like I said, think this is the same and still, behaving the same way. So again, virtual functions are rubbish. They're not needed. Because again, you can overwrite functions like I demonstrated in code in earlier videos. You can overwrite functions without using a virtual keyword. That's really not necessary. There apparently is a use when it comes to abstract data types or whatever of the virtual function keyword. At least I guess that is a requirement. But because see, when I was doing this, I was thinking that this was a necessity, that you had to have a virtual keyword in front of any function that you wanted to override. Oh, but apparently not. Obviously you don't. It does tell people that, hey, this function might be overridden, but then again, I mean, if you're not going to put virtual in the derived classes, why would you put virtual in the parent class? That's silly. I mean, you're really just doing it for, again, to try to clear up for programmers that these functions may override others, but since there's, it's not enforced, there's no real reason to do it except to try to document your code, otherwise it's just more typing, that's unneeded, because it's just not necessary. But to me, it's kind of obvious that you could have functions that override functions in the parent class. I mean, that makes sense to me, as part of inheritance. I mean, I'm not surprised at all that you can actually change out any one of these, in a derived class. I would expect that. But it is good notation to do that, if you can, because of the fact that, you can look at the base class and say, oh, this is virtual, so, it might get overridden. Now let me undo what I did. Okay, so we got the virtual version of it, and just for shits and giggles, I'll rerun it again. So again, doesn't seem to change anything. Maybe you can tell on video. Something I can't tell here. But yeah, I mean, it's good annotation, but to me it would only be good annotation if you actually did that in all the derived classes too. Like if we're to put virtual here, yet, and then virtual down here, showing even though this is a grandchild, third generation, it still annotates for people that, hey, there's actually a more, primal class or primal version of this function that you can access if you want to using the scope resolution operator, which you should be able to do. But you can see that really doesn't change how the program worked at all. But it is good notation. It's good to notate your code that way, because it shows that, hey, there is, hey, Mr. Person looking at my program, or hey, me looking at my program 2 years from now, and there actually is a base class function. This is overriding, but it's not necessary to use it at all. And so just keep that in mind. Now this, how I'm setting this up. Okay, get child, son, grandchild, grandson. So yeah, grandson, dot, and these are all the functions you have available, all the members you have available. So you get child identity, child name, common, which common I think came from the base class, grandchild identity, grandchild name, identity, parent name, parent identity, and relate. So you got the full gamut of functions available here. But let's have a look at the base class here. It's child. Okay, so this is parent, and all these functions, common, virtual identity, and parent identity, p identity, come from that. So grandchild, like I said, dot, oh, damn it, grandson dot, so you got p identity, we got identify, but again, that's going to be the overridden virtual function. And then we got should have common as part of it too. Shit. And we do. So, we have access to all of those functions. Now, that's nice and dandy. So, those are all the inherited functions. Now, if I go grandson scope resolution, which I don't know if I can, obviously I can't seem to do that. Oh, there's something missing up here that bugs me. Okay. Alright, so let's have a look at this. Parent dot, so these are the, 4 members we have access to. Common, identify, and p identity are all methods, and then parent name is, an actual member variable. So we got that available. And then as child, child has these, the inherited stuff plus, a couple of a new member and a new method, new member variable and member function. And then of course grandchild we've already looked at, it has the whole gamut. Now it could be, okay, let's look at, well, I don't want to deal with that. That doesn't make sense. Okay, we got a grandchild pointer declared here. Okay, and you can see that, right? No, I guess you can't use the scope resolution operator like that. I don't know, I'm going to have to look at the code, but again, I thought you could actually drill down and access the, the parent's identity function in there, what was overridden as a virtual function. Let's go just look at what the code does here. And again, we're back to the same thing, that we're dealing with earlier. That code up here that I said is totally useless. I mean, same thing, we got some pointers, being defined as pointing to the parent class, but yet, trying to access the sun, or which we can access. Okay, let's have a look at that though. The pointer child. Well, it's pointer grandson. Let's look at that. Okay, yeah, no, I mean, it could still only access the members of the base class. Again, it makes no fucking sense at all, to have something like this. What good does it do to have a pointer, and like I said, up above, remember, we're not dealing with pointers, we're just dealing with the, well, we are here. I mean, we're dealing with pointers, but like I said, even outside of pointers, even if you're trying to access it, with an actual stack-based instance, it's still, you're no better off. I mean, you're still not going to be able to, because the thing is, okay, is I can't like declare, like a regular instance of a class, and I mean I can't actually do this. There's no, with outside of pointers. I mean I can't, say base, equals anything. I mean I can't, I can't really do that, and I can't. Yeah, because see, I can't, since that's not a pointer, my class is not a pointer, I can't, access members of the heap, and I can't, sure as hell can't, play like it's some other class, So it's like I said, outside of pointers, you can't even, you can't even do this kind of shit. So, and that's what we're doing down here, It's just, what good does it do, okay, to declare these parent pointers, okay, and set it to type son or type grandson when you can only access the parent member data, because that's, in fact, that logically is what you would kind of expect it to do. You would expect it to only be able to access the parent, and that essentially is what it's doing, even though we're pointing it as apparently as an instance of son, or grandson. In other words, we're wasting memory on the heap by doing it this way. I don't know why we'd want to do that, because again, you can't access any of that shit, and this pointer is the only way to access it because it's on the heap. So I don't at all see why the shit you would want to do that. You really are just wasting memory. You're actually putting a buffer there, that contains a bunch of, crap that you can't, you don't have access to. I guess the question would be, okay, if I did it like that, could I can I do this? Yeah, grandchild. Pointer type. No, can't do that. So son 2. Okay. So I'm just going to declare the son 2 pointer, okay, as a type grandchild. So now can I set son 2 equal to our pointer grandchild, or yeah. So no, apparently I can't, because the thing is that, you know, even though I can point this thing to an instance on the heap, you know, of that class. Well, hell, that's not even of that class. What the fuck is this doing? Okay, child son. Well, yeah, it is. I mean, okay. So basically, let me chew on this for a second. Yeah, I was getting confused because, because of this program up here putting shit out on the heap. I was assuming this was doing the same thing, but it's not. I mean, we're basically creating an instance of it on the stack, okay, and then we're creating a pointer of type parent, and then just pointing to that instance on the stack. So down here, as opposed to what we're doing up there in grandson. Okay, so these are, but in any event, still I created a pointer here of son, calling it son2, then I'm going son2 equals pointer grandchild, and pointer grandchild is a class parent, so I can't actually set them equal to each other because they're of two different types, so it doesn't equate this type to that type, even though I can point this pointer to this object, which is of a different type. So, but I can't work it in reverse. I can't, create a son that's a grandchild pointer and actually point it to the base pointer, because that's what I was trying to do. I was saying, well, okay, if I could take a pointer like this, it's pointing to a grandson object, for example, that we created out in the heap, but again, this isn't on the heap, so you don't have to worry about it here. So since it's not on the heap, I can always access um, the member variables and the data, the methods, or the members of this instance by directly, just from here, but I can actually access the base class methods of this object, this particular instance of this object with this pointer. So I can modify its base class data, as the case may be. I still don't know why you'd want to do that, but this does allow you to actually modify a particular instance. The base class data of a particular instance. And the same here for the son. It's actually creating a, because either of these pointers could be pointed, like pointer child, I could have pointed to grandson too, because and access its base members. And I assume too that I could declare one of these pointers as like a son, a child pointer, and have it do the same thing for grandchild here. But again, I still say it seems a little pointless. But certainly a way of determining what are the member variables and so forth. So, this is pretty fucking confusing and pointless. I don't know why I'm spending so much fucking time on it. That's interesting. Okay, well, yeah, that doesn't make any sense. Well, yeah, it does. Yeah, yeah, that's fine. I mean, 'cause that's, that should, that's how you normally do it. That's how you normally access, make a pointer to that object. Um, but the question is, can I do it to grandson? Yeah, I can. So, yeah, child name, child identity. So I've got access to, you know, the child members and the parent members, but not the grandson members. So that's what that shows. And remember, anytime you're calling a function, put the parentheses. Otherwise, if you don't put parentheses, the compiler thinks you're talking about a pointer to it. Let me put this down here. Oh, god damn it. Okay, I'm going to put that down there so it's grouped. Because I do like defining my variables as a block and everything, but, it just gets a little confusing doing it that way if you're trying to look at the code. Okay, so again, I'm still not sure about the practical reason, but you are accessing a particular instance, of the class, and you are able to access its member data, and kind of peel it back like an onion. And again, this is of an actual instance, it's, you're not access, because when it comes to, when it comes to classes, okay, there's a place in memory for all the methods, and it's possible to access the methods of a class even if no instance of a class exists. So, because they're still all defined as like a, for lack of a better word, a template, not a C template, but a template of a class in memory, of the functions in memory. And the same holds true for static variables, and it's stored in the static area of memory. Um, so, um, even if you declare functions out on a heap, there's still a static version of the functions declared and all that shit in essence. But again, it's actually technically in program code. Um, but the point is that when you're dealing with actual instances, this is a way of accessing instance member data with a pointer that is inferior to the object you're referencing. Because again, we're trying to reference the grandchild, or the where is it? We're trying to access the grandson type with a child pointer. Just like up here, we're using parent pointers to access grandchildren and so forth. Well, that doesn't do you much good because you can't access the grandchildren's members or the child's members. with this type pointer, but we can, access at least the parent members. So it kind of filters it out, for what that's worth. Um, and that probably would allow us to access I, this version of the function, for every member. So, like here, we could access the identify function of, of the, that hasn't been replaced, the virtual level of it. And that's probably what this is trying to teach you. So basically, if I were to go pchild dot identify, that should give us well, that'll give us the child's function. That'll give us the child's version of the virtual function. Okay, let's do that. Okay. Alright, so let's see what that does. Okay, so I am the true child. Okay, it says I am the grandchild. That's interesting. That's very, very interesting indeed. So, even though I'm accessing p-identify, it's actually bringing up the grandchild's, with the the child pointer type, it's actually bringing up the grandchild's identify function. But again, we can, even though we don't have full, so that might be a reason to use virtual keywords. That must have something to do with it, because again, pchild, I can't access the grandchild members and methods directly, but I can access the identify function, the one that's been replaced. Okay, pointer child, let's look at that. See here, I can access just the basic methods of the parent. So let's run that. Let's see. Oh. See, it thinks I'm see, that's what I'm saying. Always watch your functions. It thinks I'm talking about a pointer there. Okay, so basically it's saying I am the child, even though, so it says I am the child, even though, you know, it's actually a parent class identifier. So that's the the difference. That's how it works. Basically, is that yeah, you can't access, with this pointer. And again, how they name these fucking things is what confuses the piss out of me, out of that book. But this pointer child, is actually a parent pointer. Okay, but the point is, it can point to a son object, um, from a derived class, and the thing is that it can access all variables of its type. Just like this pointer here can access all variables of child type, except that when it comes to virtual functions, that have been replaced, it will access the grandson's virtual function here, not the child's virtual function. And the same here, this is accessing, the well, this is not accessing the parent's virtual function, it's accessing the son's virtual function, the child class. So again, that's what's basically happening, is that every other function that it can access, it can only access, the function of the members of its base type, or of its class type. But when it comes to a derived class, it can access the virtual method of that class that replaces the, God, this is fucking hard to explain. It can access, the virtual methods that replace the base class virtual method. So, so that method you can have access to. Since we have the virtual function, you can have access to the most current one by using this technique. So if you had a shitload of virtual functions in there, well, then you could access the current one, with a base type pointer, an inferior pointer. You could actually access an advanced definitions of virtual functions of the class object type you're referencing. But again, this only applies to particular instances of the object. So otherwise, you're stuck with being able to modify inferior or ancestral versions of the members, with the exception of the virtual functions, which you can access the most current, using even a base pointer. So again, I don't know if this is useful, and it's so fucking confusing in a way that I don't know. I mean, if you had like, a bunch of pointers, that were generally pointing to an inferior class, an ancestral class, but then for some reason you needed to access the virtual functions, and well, anything that's virtual, I guess. I don't know if virtual is limited to just functions or not, but the fact of the matter is that anything with a virtual keyword could be accessed to a more advanced, a derived instance, of that class. So, it allows you to do some probing that otherwise wouldn't be easy to do with a pointer that is inferior, that's ancestral in nature. So, but again, that may come in handy if you can ever actually figure it out. If you can ever actually glue the idea down in your head of what the fuck it's doing and why you might want to use it. But that's essentially what's going on here, and that's probably what all this crap is trying to teach you. That would be my best guess. But again, as far as the practical application, I don't know. I mean, I'm not sure when you would ever need this. It seems like an obscure topic. Um, and these books, sure as hell, don't try to give you practical reasons why you would want to use any of these fucking things. And the book that I got this out of was that short, teach yourself C++ and you know, whatever. I mean, I forgot what the name of the fucking book even was. But anyway, it sucked. So, but it was, a short book. It was only like a couple hundred pages. But anyway, this is just some of the examples, and a lot of the examples are totally useless, and you're like, what the fuck? You know, I mean, because in C++ books, they're all useless, pretty much, because they're all console applications. But boy, this takes that to a whole new level, because it's not only useless console applications, but you don't even see what the point of what they're teaching you is used for. At least console application, or the thicker C books try to at least explain a practical use for it, even if the programs, aren't very good. I mean, they're typically better than this thing. Um, but I hated this book too because it never once listed a whole block of code. You had to type it in following instructions. And holy shit, how lame is that? But at any rate, that's all this is teaching you, as far as I can tell. I wish there were a simple way to explain this. I would go make a video about the simple way to explain it, but I just, I don't know. And since I don't see the point of it, um, you know, uh, but anyway, that is something, like I said, interesting about the virtual keyword is that it does give you that functionality, if nothing else. Otherwise, it's totally unnecessary. So I'll just make a short video about that.